and at some start point and moving in the negative direction, it's going to stop, turn around, and come back. The question was at what time will it be at negative 50 meters? Well, negative 50 meters is over here. It's never getting that far. It turns around before it gets there.
Does it only goes to the negative 15?
Sorry?
Does it only goes to that negative 15?
It's at negative 15 meters per second. It's slowing down. It's probably going to go closer to what, 30 meters this way, or actually probably less.
So what would we put in that situation for that answer? Just not applicable?
Never.
Yeah, never works. Impossible. You jest.
How would you do it on the third equation though, since that you got all the information in there?
All right, if we did the third equation, we'd have negative 50 is equal to negative 15t plus 1/2 7t squared. We have a quadratic, and so the way you solve a quadratic, you can either complete the square for those who like torture, or we can get everything on the one side and use the quadratic formula for a different torture. 0 is equal to 3.5t squared minus 15t plus 50. Getting everything on the right. If you want to divide by 3.5, go for it. But so t would be 15 plus or minus the square root of 15 squared plus, that's the plus or minus, minus 4 times a times c over 2 times a. What we have under the radical here should also be negative. So we're still going to end up with an imaginary answer or complex answer. So when you run into that again, either you made a mistake or the problem's impossible. And just sort of try to run through as best you can. Run through, does it make sense that it could be impossible? Well, if I'm moving to the left and I want to figure out what time I get to negative 50 meters, is it possible I didn't get that far? Yes, it is possible.
How often do you put questions that would have no answer on tests or quizzes?
On purpose or by accident?
On purpose.
You know, it probably comes out to one impossible question on the first test. The impossible, the fact that there's no answer, not impossible as in you can't do it.
There's just like this is.
Yeah, yeah. But I don't want you to think, oh, I have answers for everything. Nothing's impossible. Don't get into that type of thinking. But don't put it past me to maybe I'll put 2 on. All right, the second one is possible because he's going to turn around, he's going to shoot off. I know he goes out to 258.5 meters, so he will definitely get to 50 meters because he starts at 0, he ends up here. He's going to get past 50 at some point. So let's do it. Delta S equals 50 meters. VI is negative 15 meters per second. The F, don't know. The A is equal to
Plus 7 meters per second squared.
and time we don't know. All right, so let's again do the 2 approaches. We'll solve for VF first using the second equation. VF squared is equal to 15 squared plus 2 times 7 times 50. So that's going to be 225 plus 700, 925. So VF is 30 something.
30.411 meters per second.
that is the final speed. What is the final velocity? In which direction is the object moving?
To the right.
Given the way I'm drawing it. Yeah, I'm over here. In this scenario, he goes to the left, turns around, and comes back. At this point, he's only moving to the right. So he's moving in what I've implied is the positive direction. So my final velocity is positive 30.41 meters per second. And so now I can find time using the first equation. Vf equals Vi plus AT. 30.41 is equal to negative 15 plus 7t. And then 5.41 divided by 7, which is 6 point something. 6.73. No.
6 point.
What is it?
6.48.
40.
Wait,
49.
6.49. Second.
Yeah, it's time.
64.19.
No,
But that's 6.49.
Okay. There we go.
Some students in the past do very light dots, and I can't tell whether they're off by a factor of 100 on something like that, or whether there's a dot there. I do my best in trying to figure it out for some students. Others, it's very clear. All right, so for this one right here, the answer is 6.49 seconds. Now, questions up to here before we talk about distance and speed. What is the distance the object traveled? Well, it's not, if an object changes direction, the distance is not the magnitude of the displacement. So he goes to the left. I need to figure out how far to the left he goes. Then he goes to the right. So if I can figure out how far he goes to the left, the rest of it is just a matter of thinking and addition. So what do I know about the trip to the left
Velocity is negative 15 meters per second
initially?
initially. And it accelerates uniformly at 7 meters.
All right, so
per second.
cruise down that path. So I have delta S, VI, VF, AT. This is 7 meters per second squared. This is negative 15 meters per second. I have only two things. I need a third thing.
The velocity will be 0 when it stops.
Yes.
Wait, it's going to stop.
You turn around, it has to stop. It's not going to get, if it has a negative velocity and a positive velocity, it has to pass through 0.
Okay.
Unless you're in the realm of science fiction.
So
Which-
how's that different from the ball?
I said different than what?
The ball going up and down?
It's not.
Crazy. Crazy.
Okay, this is an object, the other's a ball. It is completely different.
Are you serious?
That this is an object?
The ball is an object.
Are you sure?
Yes.
Who raised you? Nice look. I can't do it. All right. Find time, I think the first equation makes the most sense. Again, if in doubt, just plug into everything and see what equations have a single variable. But, so I've got 0 is equal to negative 15 plus 7t. So t becomes 15 sevenths. If I had gotten negative 15/7, that would have been a warning flag of something's off. Or in decimal form, 2.1428557.
Do we have to write all of that?
No.
As a, you were just showing out.
Yes. You know, it's one of the ones I can do. All right, so we now know the time. I now have to figure out how far he goes in that time. So I'm basically solving for delta S.
Second or third equation? Or fourth?
Actually, I could have used the second equation, just gotten displacement directly. Oh well.
We'll go third.
Sorry, so which one are you suggesting?
Third.
I heard third and something over there. All right, so using the third one, negative 15 times 15/7 plus 1/2 7 times 15/7 squared. Now I would expect there to be a negative number. If it's not a negative number, something's off, because I'm moving to the left this entire time, except for that stopping at the end of this path.
Negative 24.64.
Negative 24.6964 units. Now, it's an intermediate part of the problem that's not, we don't have to put in the units at this point. But, so what I've got here, what we have here, we go to the left, 24.64 meters. I know it takes me that far, that's the distance I traveled to get back to where I started. 24.64 meters to get back to here. And then I end up, I've already found that, that's 258.5 meters. So the distance traveled is just the sum of those three numbers.
Okay.
And so the distance traveled,
I didn't get that. I didn't get that answer.
oh, you didn't get 24.64?
It's negative 16.07.
Negative 15.6.
16.
I got that same.
16.07.
Or we have general consensus that negative 16 is right?
Yes.
Yes. So I travel 16.07. 16.07 to get back to the starting point, and then 258.5 to get to our final displacement. And so the sum of those three numbers. And we end up with
317.64 meters.
no.
Wait, are you asking for just
That plus that plus that.
16.07 plus 16.07 plus 285.5?
58.
Oh, that's why.
Can you just explain why you put, like, so the negative doesn't matter?
The negative is telling me the direction. I was expecting it to be negative. I'm trying to
Yeah.
find the distance. So
Okay, just,
the negative tells me I went to the left
okay,
in my convention here.
okay.
290.64. So that is the distance traveled, and so what is the average speed? Or how would you find it?
Just like so much time.
Ooh, maybe I misheard. Say it again, Margaret.
Was it right?
Not what I heard.
Then I have no idea what I just said.
I said distance every time.
Yes, it's that. I thought you said displacement every time.
That would be crazy.
That would be.
Oh my gosh.
Sorry, I don't know where that came from. Again, voices in my head. Poltergeist, they're creeping up front. Abigail, keep the poltergeist back there. So average speed is distance over time. So that divided by 11 seconds would give us the average speed.
26.42 meters per
Better?
second. 26.42 meters per second.
And that's greater than the average velocity. The average speed is going to be greater than or equal to the magnitude of the average velocity. Pratika?
So for this problem, we were able to like sketch out something for the problem, but what if we're not able to figure out what's happening? We would not be able to do the distance. Do you have any tips?
In a problem like this, where you're trying to find the distance, it's a one-dimensional problem. If it were a two-dimensional problem, like I was throwing a ball into the air, we're talking about calculus and line integrals beyond the scope, of course. So it's one-dimensional, an object is just moving back and forth. So if you can't picture what's going on, you can ask. There'll be a limit of how much I say, because part of what I'm testing is, your ability to picture that it starts out in the negative direction, it ends up in the positive direction, so it has to turn around at some point.
Because the final displacement is positive.
Yes. Actually, more specifically, because the final velocity was positive.
So you wouldn't give us that graph, like, figure, we would have to just know that,
Oh, the drawing at the top?
the graph, yeah.
Yes, you would, I would assume you would be able to do that. When it's necessary, when lives are at stake, you'll be able to do it. That's why we will have swords hanging in for all of you. That was a lot darker than I intended. It's supposed to be sort of a, light, airy violence kind of thing. Questions? All right, so let's go ahead and establish, today is the 27th. Master set 2 is due a week from today.
If it opens today?
Pardon?
If it opens today?
We'll find out.
Alright.
Well, I've been told no, but it should be before the end of today.
Alright.
The lab that we did yesterday, will that be due next Tuesday as well, because we don't have school on Monday?
I originally said it that it was due that Tuesday, but then I thought, no, the rule is it's due the next time we have lab, so I made it due on the 9th.
Okay.
Feel free to do it early.
This is due on the 9th.
On the 9th?
Yeah.
I think that's what I posted, the data posted in Blackboard for the lab should be correct.
Thank you.
Now, go ahead. Start a new video here.